So here goes back to, in terms of self-regulation, what are we supporting? Are we supporting their ability to engage in these metacognitive processes, so we need to model them for them, or are we doing it for them, okay? Are we teaching them about just purely content, okay? Or is it a combination? Well, what the literature says is you should never, if you're gonna teach skills, the skills always have to be embedded in some kind of content, right? They gotta be contextualized. That's the big question we were just talking about. When do we provide the support, okay? At what point have we sampled enough of the students' learning skills, learning behavior, in order to intervene? And if we knew when to intervene, are we effective? Okay, those are two of the big issues. Because we don't want to end up in dysregulation. And then how do we support this? Well, with many of the systems and the ones I'll show you today, is we were using these pedagogical agents that are basically avatars, okay? But there are more ways of doing this, which are with intelligent virtual humans. So, questions before I show you kind of a demo of overview of MetaTutor? How we're doing? Can I get feedback?
Good.
Okay. Do that in my undergrad class and they look at me like, you want feedback? Yeah, blink, I don't know. Just like,
Was the tutor a virtual tutor earlier up on the right-hand side? Okay.
But now, is this one gonna be the one that you said has no AI, or is this one gonna have this?
This one has the one I'm about to show you, MetaTutor, has some AI. It's more of an overview. And keep in mind as you're watching this that the content, as we discussed for our proposal.
Welcome to MetaTutor.
The content can be
MetaTutor
any
is a
kind of
hypermedia
content.
environment which uses text and diagrams to help students learn about complex science topics like the human circulatory system. The main purpose of MetaTutor is to help students learn to better self-regulate their learning by deploying appropriate planning, monitoring, and learning strategies. MetaTutor interface consists of different parts. The content area is where the learning content is displayed through the session in text form. Learners make metacognitive judgments of their learning at different times during the session. Students can navigate through a table of contents at the side of the screen to go to different pages. The subgoals learners set are displayed at the top middle of the screen, and they can manage subgoals or prioritize one here. A timer located at the top left corner of the screen displays the amount of time remaining in the session. The overall learning goal is displayed at the top of the screen during the session. A list of self-regulating processes are displayed in a palette at the right-hand side of the screen. Students can click on them throughout the session to deploy planning, monitoring, and learning strategies. Static images relevant to content pages are displayed beside the text to aid learners in coordinating information from different sources.
Just open up, it's not just.
Text entered on the keyboard and students' interactions with agents are displayed and recorded in this part of the interface. 4 artificial agents help students in their learning throughout the session. These agents include Gavin the Guide, Pam the Planner, Mary the Monitor, and Sam the Strategizer. MetaTutor is designed in a way that all interactions of learners with content, agents, and the learning environment is recorded in logs for further detailed analysis.
So just an example, an overview. And some people ask why 4 agents? Yes, we're probably the only system that exists right now that has 4. Most have 1, some have 2, and very few have 3. We did 4 because we wanted students to associate, this is part of their training, that when they see Mary the Monitor, that Mary's for metacognition. So when she pops up, it's something related to your ability to metacognitive monitor, versus Sam the Strategizer, that's for learning strategies, versus Pam the Planner, like what goals should you be setting. And we know from our literature that the most hated agent is Sam. Because Sam is the one that makes you work, right? I want you to summarize now. I've been watching you for 15 minutes, you've been reading this content, looked at these diagrams. Now tell me everything you know about pulmonary circulation.
What's the column on the right for?
This one, this here?
Yeah.
So we moved away from think alouds like you saw in the first video, okay, because they're just, you can take a whole lab and just kill your lab by having them transcribe and code. So we try to come up with a proxy for not including think alouds. So they're trained on these are some of the self-regulatory processes. So for example, if you want to make an inference, you can actually click make an inference, or you want to take notes, you click take notes, and a notebook actually pops up. Okay.
I have a question.
Yes.
Is most of the system based on the student
the content and inspecting the diagrams. So, and we're getting more sophisticated because, for example, with eye tracking, we're now basically able to hack into the eye tracker. So there's a whole area of computer science which is user interface, intelligent user interface. And so the question is, now imagine being able to use the eye tracker not only when they're using the system, so we can analyze that data post hoc after they're done with the session, but imagine collecting the eye tracking data in real time, right? And imagine that a prolonged fixation on SAM, right? There's no verbalization, a prolonged fixation, we may say that that is related to them trying to engage in help seeking. So then imagine that actually prompting Sam to, it's like, I notice that you're looking at me, do you have a question or do you need some help? Okay. Or having a student, for example, look at this white blood cell, right, and keep staring at it, and it sees a particular threshold that you, for example, would say, well, we're not sure what their student is doing anymore, right? So they sees that threshold, and all of a sudden, it could be Sam or Mary the monitor, and indicate, we notice that you've been staring at this white blood cell, you know, is there something in particular that you want to know about it? And then you can guide them. You get them to the text, you walk them through, well, white blood cell's not, at least not very interesting, but hey, it's a cotton ball, yeah. Right? So more ways of making it adaptive in real time. And that's eventually where we want to go. Okay. So this is somewhat what it looks like. We also have changed it so based on the number of pages, the student has set some goals, okay? And we try to indicate through color that basically for this sub-goal, they've looked at half of the pages that are available. They haven't looked at all of them. So some way to provide that kind of visual feedback, which would be good for students. And of course, the psychology behind this and the learning behind this is that, you know, they're all given an overall learning task, which you can manipulate, right? Of course, the overall learning goal could be related to the kinds of learning goals or objectives that you have for your students, right? We have them set sub-goals. They engage in knowledge construction activities. They obviously, back to your question, they read pages, inspect diagrams. That's kind of the very macro molar level. But then we expect them to engage in several cognitive processes, metacognitive processes, okay? And of course, affect. And in terms of affect, we look at only basic emotions like fear. It's a good thing that our systems induce fear. Okay, but anger, right? It's like they get frustrated because they need help and they're not getting the help, right? Or what we call learner-centered emotions, things like confusion. Okay, what are you confused about? Okay, and then, sorry, it's generic. And then assessments, right? We of course have pre-test and post-test, but while they're learning, they also have quizzes and summaries, etc. One of the problems that we have is, not in terms of natural language processing, it's extremely difficult to not have a human expert analyze those summaries.
So how are the summaries analyzed? Because obviously the computer doesn't do it. Do they have to type it out?
They have to type it out.
And it gets sent to an instructor, or?
Ideally, the next module is that we use natural language processing where we have a template and basically that would be matched. But the problem is, of course, as we know with humans, is that we can express the same thing, especially in a scientific domain, very differently, and yet mean the same thing or completely different things. So it'd be good to have the agent then actually help me clarify. So get the student more involved. Help me clarify what you wrote here in the summary. That could be one way to engage them a little bit more.
Could you have a student summarize and then have a list of summaries and ask them to pick the best summary?
Yeah, that's another way, Dennis, yeah. You have, for example, so you have the expert summary, one of your summaries, or if it's something that's not so clear, you may have multiple expert summaries. And that's kind of, we ran into the SICU unit training, because when we looked at nurses, the expert nurses, they all had a different approach. They all came to the same conclusion that it was hypovolemia, but yet they did not follow the same problem-solving process. So the question is, oh my gosh, this is an ill-structured task. So let's provide the traces of different nurses, and the student nurse can basically reflect and compare. Mm-hmm.
Dr. Azevedo,
Yes.
under cognitive processes there, what are the first acronyms when they?
Oh, judgments of learning, okay? So that's kind of, are you aware of your emerging understanding of the content? Versus feeling of knowing. It's like, oh, I remember doing that in class last week or in the lab. So basically trying to anchor what you are reading or inspecting with something that's already in your long-term memory.
You're not measuring. Can you measure those two things though?
Well, we use different approaches, that's right. So that's one of the puzzles of the pie is how do we measure some of these? So these we can use metacognitive judgments from like a Likert type scale from 0 to 6. How confident do you feel you've mastered this content if I give you a test right now. And then we look at calibration. Oh, overconfident. Oh, I'm gonna do really well, and then you get like 30%.
Or, you know, a lot of us are using the Connect. If you go into the Learn Smarts in Connect, the first question you get is, how well do you know this? I know it, I'm confident I know the answer to this question, versus I'm just guessing, versus I have no idea. And then you could compare that to what they actually do on the subsequent question.
Yeah, so we can ask them for the judgment, right? They'll do the quiz or some kind of assessment. Let's look at the calibration and then see their subsequent learning behavior, right? And if they're not doing it right, then it's time for some kind of coaching from one of the agents, right? So we have different techniques for measuring most of these, and that's what I'm going to show you also as kind of sample data. Oh, I'm sorry.
Question. What's the difference between judgment of learning and feeling of knowing?
Yeah. It's tricky because judgment of learning it's in the real time, right? So I imagine I've never seen the four chambers of the heart. I'm from another planet, right? So I'm looking at this for the first time, right? So we kind of control, like, so the assumption is that you have never seen this before, right? So I'm looking at it for the first time and I'm inspecting the diagram. And then the question is, am I understanding what I'm doing? And this is one of the ones that is extremely difficult because it's so covert. And unless somebody utters oh, I don't understand this. Oh, perfect. From a language perspective, from a linguistics perspective, that's perfect. Because I can segment that and I can add valence to it. Because it's the don't, right? So we gotta find ways, so that's a trick. Versus, I know I've seen this before, whether it's grade 8, grade 12, last week, right? The problem is the feeling of knowing, as you see it through time, right? So students using the system for an hour, 2 hours. Judgment of learning then becomes a little bit muddled because, well, now you've seen the diagram because you may go back to the same text or the same diagram. So we got to figure out ways of teasing those apart. Okay? Some of them are very rare. It takes a very sophisticated student to actually be aware of the use of their strategies. And when you're doing a thing about protocol, this is really interesting because these would be the very rare 1 to 2 students in a sample of 100 who say, you know what, summarization really works when I'm learning about X. It's like, wow, that's great. Okay. But the question is, are you really doing it correctly? Okay. In a hypermedia environment or any content, because content evaluation is always very frequent because you're looking at text, diagram, static, or perhaps an animation, right? So you always have to engage in content evaluation. Okay? So, MetaTutor has different, what we call layouts. So this is the normal view, so you got everything here, but you know, some students get a little confused, so you know what, get rid of all this stuff, let me just focus on the text and diagram. That's all I'm gonna do. So we also measure when they shift from one to the next. Here's the notebook, okay, that comes up. Unfortunately, the notebook does not allow them to draw. So we do have an external drawing tool. Okay, so we've noticed that anytime they want to draw, they go to the external drawing toolbook. Anytime they just want to type, okay, they use the online version, okay, and it helps them put together their summaries, okay, and their notes, excuse me. Here's the metacognitive judgments, okay, the Likert type scale I was telling you about. And then we also have the dialogue between all the agents and the students, and we can analyze that. And the quiz, of course, when they're doing the quiz, we strip them of all the content. So these are some of the layouts that are available. From our perspective, you know, in a typical study, or if we're working, depending on who you're working with, of course, all students are probably randomly assigned to some condition, whether it's a control condition where the agents don't speak, don't talk, don't help, versus when they do. And so hypothetically, from pre-test to post-test, you know, they may set some sub-goals, right, like these two. And while they're learning, it could be 1 hour, 2 hours, 3 hours, no matter how long, they're gonna be engaged in some knowledge construction activities and assessment activities. And then the question really is up to us as researchers or educators to figure out what's our research question, okay? Because we can mine the data, you know, until the cows come home. So the question may be, I am very interested exactly what is happening at that point in time. And that point in time may actually be a certain sequence. They were given instructions by Gavin, they looked at a particular content, and there was a sequence of content, Then Sam told them to do something, followed by Mary telling them to do something else, or prompting a metacognitive judgment, and then when they went back. And we could go all the way down to the word on a page or the diagram on a page level. So our question is to figure out how do we decompose these self-regulatory processes depending on what our interest is. Okay, so that's more from a research perspective. Does that make sense?